Hello, my name's Mark Williams. I'm a professor of psychology at the University of Leeds, and my research is about perception. And so this is the third of a series of 4 podcasts talking about perception. So in previous podcasts, we talked about what perception is and why perception is so important to us. We talked about why vision is such an important source of information to humans. So what I want to do in this podcast is consider the organ responsible for providing us with visual information. I want to talk about the eye. And one of the things that we're often taught about the eye is the fact that it's like a camera. And what I want to do in this podcast is see how useful an analogy that is. So, here's a camera. So let's first of all think why people have drawn an analogy between the camera and between the eyes. So one of the similarities between the eye and the camera is that they both have focusing capabilities. So if I look through the camera at something far off, then I can turn the dial to make things nice and clear. If I then want to look at something close to, I look at it through the camera, it's a little bit blurred, so I turn the dial and I can focus the camera so everything's nice and clear close to. And the human eye has a similar mechanism. It's called accommodation. So if I look at something far away, I can see it nice and clearly. And then if I want to look at something close to, the lens inside the eye changes its shape. There's a muscle around the lens. And by contracting or relaxing the muscle, I can change the shape of the crystalline lens inside the eye. And that allows me to focus on things close to. So the eye changes focus, camera changes focus. So 2 similarities. What other similarities are there? Well, one of the things that you can also do on a camera is you can adjust the aperture. So you can adjust the hole that controls the amount of light that's let into the camera. So if it's a very, very bright day, then you want a small hole. But if it's a very, very dark day, then you want a larger hole. And you can adjust that using a camera. And the eye also has a mechanism that allows it to adjust how much light is let in. And so that's the pupil. So that in bright sunlight, you have a very small pupil. And in dull illumination, so in a dark room, the pupil enlarges to let more light into the system. So there's another similarity. So your eye has a focusing mechanism and it has a mechanism that allows you to alter the amount of light that enters the eye. So 2 similarities. And there's one more similarity as well that people are fond of pointing out. So the other similarity is that the camera has a light-sensitive film. That's what allows us to take pictures. And at the back of the eye, we have an area called the retina, and the retina is sensitive to light. So it's a photosensitive region. It's a region which is sensitive to light, and the camera also has a region which is sensitive to light. So 3 similarities between the camera and the eye. Well, the purpose of an analogy is to try and help you understand something very sort of complicated. And I'm not sure that drawing an analogy between a camera and the eye is that useful. I think without the analogy, we can still understand the idea that the eye's got some focusing mechanism, that the eye can regulate the amount of light that enters, and that the eye has a photosensitive layer at the back. So there are some similarities between the eye and the camera, but I'm not sure that it's a very useful analogy. And what I'd like to do is point out the fact that there are some really quite large differences between the eye and the camera. I want to point out 3 fundamental differences between the eye and the camera that hopefully will start us thinking about the eye in a more useful way. So one of the first things that I want to point out is that the eye is a living organ. And because it's a living organ, so it's subject to nasty diseases. So I've got a book here called Common Eye Diseases and Their Management, and it just talks about a number of the different things that can go wrong with eyes. And there's a whole branch of medicine called ophthalmology, which actually specializes in trying to treat eye diseases. So eyes are living organs, and because they're living organs, they're subject to diseases, and it's important that we understand these diseases so we can prevent blindness. And the thing about a camera is it's not a living organ. And cameras don't get diseases. So one difference between the camera and the eye is a living organ. But there are other differences between the eye and the camera. And one of the differences that I want to emphasize is the fact that the eye is an organ that develops. So when you first get a camera and leave it, nothing happens. The camera stays the same. But that's not true of the human eye, because the human eye develops over the lifespan. So when we're first born, we're actually born with a condition that we call hypermetropia, which just means we're long-sighted. And effectively, that means that the eye's too small. What happens over the first few months and years of life is that the eye develops. And one of the things that happens is the eye actually increases in size. And that means that the rays of light don't naturally fall behind the eye, which happens in the case of hypermetropia, but the rays of light end up at the back of the eye. So we end up with a condition that we call emetropia, or perfect eyesight. And emetropization is the name given to this process, a process by which the eye starts off too small and then grows until it's just the right size. And that's a really amazing process. So newborn babies are born with hypermetropia, or approximately 2 to 3 diopters. They're the units used to measure the refractive error of the eye. And then over the first 6 months of life, typically that hypermetropia disappears and the children end up with perfect eyesight. And the important point about this process is that it appears to be under active neural control. So the brain is actually controlling the eye and making it grow till it's just the right length, so everything's nice and clearly in focus. Of course, that doesn't always happen, and so sometimes the eye doesn't stop growing, and people end up with what we call myopia. It's a little bit short-sighted, where the eye is just a little bit too large. Or sometimes the emetropization process doesn't start, and so children end up being hypermetropic. But for the vast majority of people, the eye grows till it's just the right length, and you end up with perfect eyesight. And the important point is that the eye is developing. It's developing from birth, and it's tuning itself to the environment. And that's not like a camera. And the third point that I want to make to differentiate the eye from the camera is that the eye is where information processing starts. So we've talked about the process of perception. So perception is the process whereby we obtain information about the world. And the supercomputer, that's the brain, detects and interprets information to tell us about the world and tell us about our relationship with the world. Now, a camera takes a picture, but that's it. It doesn't interpret any information. It's the genius of the human brain that interprets the information provided on the photograph. The retina, the photosensitive layer at the back of the eye, doesn't simply take a picture. The layer at the back of the eye, the retina, processes information. And I prefer to think about the retina not as some simple static camera film, but as an active supercomputer where the very early processes of visual processing start. So the retina itself processes information from the world, and then it feeds that information back to areas of the brain which are specialized for particular jobs in visual processing. And that's going to be the subject of our next broadcast. Thank you.